Cisco Certified Network Associate Day 34. Welcome back everyone, I'm Imran Rafa, your trainer for this entire series. Today we're going to look at VLAN Revisited, and if you know, we have already done VLAN in our old video. I think it was days 11, 12 and 13. So we have done VLAN, but we're going to revisit VLAN, and one of the main reason that I'm going to revisit VLAN is because after a lot of recommendation that I've got in my old series, no, when I say old series, it's the same series, it's a continuation from there, but then till day 33 we completed ICND 1. So if you watch till day 3, you are ready for ICND 1 and you can write your exam. And I think I recorded that video about a couple of months ago, and I've been very busy in the last couple of months. So for all those people who watched all the videos till day 3 and you have gone and attempted your ICND 1, and those of you who have come out successful, congratulations. And others, if you have not yet attempted, I think you're ready for it. You could write your ICND 1 exam or wait until we finish this ICND 2 that is starting from now, maybe another 30 or 35 videos. So once we finish that, you could write 200, 125, the composite exam for ICND 1, right? We have discussed that in our previous videos. So if you're not done, if you keep following from day 1, you would see somewhere in between the process and what are the different types and ways with which you could write your CCNA and get your CCNA exam, right? So that was that. We're starting a brand new series, ICND 2, from now onwards. So if you're following from day 34, this is going to be ICND 2 topics, and a lot of people have asked me why we have not covered our OSPF or EIGRP in the previous videos. Well, the reason is OSPF and EIGRP is not part of ICND 1, it's part of ICND 2. So wait for it. From now onwards, you will be covering ICND 2 topics, and of course you will have OSPF and EIGRP. So let's not waste much time, but just before we start, I need to show you one thing, the way we're going to structure the videos. I mean, with ICND 1, I have not followed any set pattern. I've just tried to logically flow the data or flow the topic such that it was easy for you to understand. Well, now we are in ICND 2, and like a lot of people have requested, we will follow the Cisco's syllabus. So if you go to Cisco's ICND exam topic on the website, like the link that you see here, you will see the topic that ICND 201-105 ICND 2 is following. So you have basically 5 broad topics: LAN switching technologies, routing technologies, WAN technologies, infrastructure services, and infrastructure maintenance, right? So what I'm going to do is I'm going to follow accordingly from here. So we will have the first video covering these, like 1.1, we'll have maybe the next one 1.2, and each subsection either is going to be one video, or maybe if the subsection is it's not much, maybe I might combine 2 of them to have one video. Sometimes I may have one section if the section is big, let's say in OSPF, in routing technologies. If one of the section is pretty big topic, I might actually split that into 2 videos, right? But we would be, as much as possible, we would be following along these 5 broad topics, and it becomes easy for you to compare your notes, right? So end of the video. So that's how we're going to structure ICND 2. So welcome to ICND 2. Yeah, and this is my new desktop. Windows 10, but the boring Windows 10 wallpaper has been changed, and I've installed some new widgets. So if you want to know how to pimp your desktop, then watch the video. I'm going to put the link right on top. This is my new video in my other channel, so you could watch videos. I will be putting more videos how to customize your desktop, and many more videos. I would be starting vlog, so that's where you should be. You can go there and like those videos, and also subscribe to that other second channel of mine. So without wasting much time, let's get straight to today's class. And before we go ahead, please go click on that subscribe button and make sure you click on that bell icon as well, without which you will not be notified. So click on subscribe and click on the bell icon to be notified of our new videos. Right, these are social media contacts for our company. On the right, you have social media contacts for myself, so you can feel free to contact me. Like I said, Facebook, you can follow me. I may not accept you as a friend, but all the other, like for LinkedIn and for Twitter, please feel free to follow me or tweet me there, and I'm actively responding there for all my business contacts. If you want to write to me, imran.rafai@nwking.org. Like I said, priority is given to people who donate to our channel, so I would be personally responding to their queries on email. But if you don't want to donate, there's no harm, there's no force. You can comment on our YouTube section right below here where you're watching this, and we have a lot of people in the community who are fellow learners like you who would respond to you. Also from our team, somebody would respond to you, to your queries, if it is really, really important, right? So feel free to comment, feel free to like this video, feel free to share this video, and let's make it easy for others to follow and learn for free. So what are we going to look at in this video? We're going to look at 3 things. Like I said, we'll be following closely to the Cisco syllabus. So 3 things for this video. That is going to be default and native VLAN. We did this in our, like I said, day 11 or day 12 video. We have done this, but I'm going to again, because there was few shortcomings, especially default VLAN and native VLAN was something that a lot of people got confused. There were some gap in my explanation, so I'm going to make it very, very clear this time. Then we will look at normal and extended VLAN, and then we will finish it with the data and voice VLANs, right? Default versus native VLAN. What is that? If you take a Cisco switch out of the box, factory setting, there are going to be 5 default VLANs. That's VLAN 1, VLAN 1002, 1003, 1004, and 1005. VLAN 1 is called as the default VLAN, and VLAN 1002, 1003, 1004, and 1005 are VLANs for token ring and FTDI, right? These 4 VLANs, 1002, 1003, 1004, and 1005 are not, it is default, you can't delete it, you can't add new, now in today's world you can't add interfaces to those VLANs because it's not going to work. Whereas VLAN 1 is default VLAN, like I said, that VLAN cannot be deleted, you can't even change the name of that VLAN, but by default all the ports of that switch is going to be part of VLAN 1. That's why it's called VLAN 1, and all the switches can talk to each other because they're all part of VLAN 1. So that is the default VLAN. Now if you go to a switch, any interface, let's say in this case this interface that's connected here and this interface that's connected here, and if you go there and type switch port access VLAN, let's say VLAN 20, let's assume this is VLAN 20, right? So if you say switch port access VLAN 20, both these ports get connected to, or it moves itself to VLAN 20. Now like I said, I mean, you please, before watching this video, I would recommend all of you to go watch VLAN day 11, day 12, and day 13 probably, so you have an understanding from what we're going to, because I'm not going to go deep again and explain VLAN and what VLAN, but if you watch that you will understand this video. So in case you do that, if you say interface VLAN 20, if VLAN 20 is not available, automatically it's going to create a VLAN 20. Other way of creating VLAN, like I said, is in global configuration mode, you can type VLAN 20 and it creates a VLAN, right? When we look at the configurations, you know, CLI, you will see what I mean. But basically, if you, whenever you type that, it puts those 2 ports in VLAN 20. Now PC2 and PC1 can communicate with each other because they are part of VLAN 20, and PC3 is still part of VLAN 1, and PC3 cannot communicate with PC2 or PC1, but PC1 and PC2 can communicate with each other. So that's one. Now what happens is, if like that's why we need VLAN, and we discussed that earlier. And again, if there is another switch, switch 2, and switch 2 also has VLAN 20, right? We go to that interface and type switch port access VLAN 20, and that particular port goes to VLAN 20. Again, switch 5 will not be able to, or again PC5 will not be able to communicate with PC4 or PC6, but PC6 and PC4 are part of VLAN 1, so they can communicate with each other. Now what happens if PC switch 1 and switch 2 is connected, like because of DTP, these two ports would negotiate a trunk. So this would become a trunk because of DTP. We discussed DTP in our previous video, so I'm not going to explain all that again. You can go back. By default, all the switches are configured in DTP mode, so they are going to negotiate a trunk, right? So this is going to be trunk, and these ports, if you don't hard code it, they are also, all these ports, like I said, are part of DTP. They're all configured by default to negotiate a trunk. But if it is connected to a PC, it would go into access mode, and we have hard coded VLAN 20, so they would move to VLAN 20. But if you want to make these ports, which is connected to a PC, into an access port, you type the command switch port mode access, right? So when you say switch port mode access, it is your hard coding access ports. And if you go to these, if you want these to not negotiate, but if you want them to be hard coded to trunk, you go there and say switch port mode trunk, right? So that's how you do that. Now, when you connect two switches to each other, it forms a trunk. It forms a trunk. That means now, if like in this switch, only traffic for VLAN 1 would go in here, only traffic for VLAN 20 would go in here. But a trunk is where all the VLANs would be sent. So all traffic going out, all traffic on the switch, a copy of which would be sent out on the trunk. That's what trunk is. So all the traffic in switch 2 would be sent out on the trunk. But if you remember from our previous explanation, VLAN is locally significant, right? So the switch knows what VLAN is. So let's say traffic coming out of PC6 and going to PC4. For the PCs, there is no, it's just a normal traffic. Only the switch will look at the port from which it comes into the switch. So it says it's coming from a VLAN 1 port. That means it can only go out of a VLAN 1 port, right? That's something the switch does. But when the traffic goes out onto a trunk, the switch needs a mechanism to explain to the next switch what VLAN it is in. That's where the concept of native VLAN comes in. Every trunk, now default VLAN, like I said, it is for the whole switch. There's only one default VLAN for the whole switch, and that's the VLAN 1. We cannot change it, right? That's the default VLAN. But native VLAN, again, by default, for all trunk, now this trunk, right, and for this trunk, by default the native VLAN is VLAN 1, right? And what is native VLAN? Native VLAN is if traffic from native VLAN is going out on the trunk, that traffic would not be tagged anything. It'll be blank. But if at all a non-native VLAN traffic, in this case let's say VLAN 20 traffic is coming onto the trunk, the switch would say, okay, you're from VLAN 20, which is not the native VLAN for this trunk. So I'm gonna, in your frame, like you if you remember from our OSI video, every layer adds a header, right? So in this frame, it's got a destination address, source address, VLAN tag, right? There is a VLAN tag, and in VLAN tag there is VLAN ID. So it's going to say this is VLAN 20 traffic, right? So when the other switch receives that traffic, it looks at the VLAN tag and it sees this is VLAN 20 traffic. So I'm going to only send that traffic out on VLAN 20 port. So in this case, that traffic can only go into PC5, right? So that's what VLAN is. So the native VLAN is there only to decide if the traffic has to be tagged or untagged. If you change the native VLAN for switch 1 on this port, you have to change the native VLAN on switch 2 on that same connected port, because otherwise you will get native VLAN mismatch, and then you could have a lot of problems. That means if let's say in this native VLAN is VLAN 20 on switch 1, and in switch 2 it is the default native VLAN. Default native VLAN is the VLAN 1, right? VLAN 1 is default native VLAN. Don't get confused with default native VLAN and default VLAN. This is what happened in the last video. I explained default native VLAN and default VLAN, and I think I jumbled it up and a lot of people got confused. VLAN 1 is the default native VLAN because by default each of those ports has the native VLAN set to VLAN 1, so it's called default native VLAN sometime. But default VLAN is VLAN 1. The native VLAN can be changed, right? And if you change the native VLAN for switch 1 on this trunk, Traffic VLAN 20 comes to this port and says, okay, now native VLAN for this trunk is VLAN 20, so I'm not going to tag you anything. When the traffic goes on this trunk, switch 2 would take that traffic and say, okay, this traffic does not have a tag, and according to my configuration, my native VLAN is VLAN 1. That means it says, okay, this traffic can go into PC4 and PC5 only. Now look at that, VLAN 20 traffic going into VLAN 1 traffic. That is a big security problem, right? You're mixing VLAN traffic, and that is not right. That's why always both the connected ports should have the same native VLAN, right? So that is the difference between default VLAN and native VLAN. In all the trunk, native VLAN has to match. Now let's go ahead and look at this from a switch perspective in the CLI. Right, so you go to a switch and type show VLAN brief. You will see there is default VLAN, right? All the ports of the switch are connected to the default VLAN, and then you have 4 more VLANs: 1002, 1003, 1004, and 1005. These are all default VLAN. You can look at the name, it says default, default, default. These 4 VLANs, 102, 3, 4, and 5, cannot be used anywhere because these are there only for backward compatibility. These are old technologies like token ring and FDDIs. We are not going to use, so it's unsupported. If you see the status, it clearly says unsupported. It's active, that's for backward compatibility, but it's unsupported. But default one, the VLAN 1 is default VLAN, and this name default cannot be changed because that's default VLAN. By default, all the ports are connected to this VLAN. That means you can have intercommunication between all the switch by default. If you want to put a switch into another VLAN, what you do? Go into configuration terminal, that's the global config mode, and here you need to create a VLAN. So you can create a VLAN by either saying VLAN 20 and hit enter. It says it creates a VLAN, and you can give a name. So we say name management, right? Hit exit, do show VLAN brief, and you can see that there is a new VLAN called management VLAN 20. There are no ports associated with that because we have not put any port in there. So we can do that. We can say interface Ethernet 0/1 and say switch port mode access. I'm hard coding this switch to be switch port access port, and then I say switch port access VLAN 20. Right? So now do show VLAN brief. You would see that Ethernet 0/1 has been added to the management VLAN. One thing you need to observe here is you see that Ethernet 0/1 has moved away from VLAN 1. I didn't explicitly ask Ethernet 0/1 to move out from VLAN 1. Whenever I configured Ethernet that interface to move to a new VLAN, it gets deleted from the old VLAN. So it moved itself from VLAN 1 to VLAN 20, right? So every access port can only have one data VLAN, and that is why it cannot stay in 2 VLANs. Now let's look at the native VLAN. So in this case, let's say show trunk. So show interface trunk. When I do that, it says Ethernet 0/0 is a trunk, and it is in mode desirable. Like again, it's not, I've not hard coded it. In this case, it is DTP has decided that what mode it should be in, and it's encapsulating in ISL, right? It's an ISL. The state is trunking. VLANs allowed is 1 to 40094. We'll discuss what is this 40094. Then what are the VLANs allowed? There is only VLAN 1 and VLAN 20 because these are only 2 active VLAN that is part that's available in the VLAN database, like we just looked at, right? So both the VLANs that's there are allowed on this trunk, yeah, about spanning tree we will discuss in future videos. Now what you could do is you can go config terminal interface E0/0. Now I can say switch port. If I want to hard code this port to be trunk, I can say switch port mode trunk. Right now this is going to be in trunk. Now again, it says you can't it says an interface whose trunk encapsulation is auto cannot be configured to be trunk. So let's say switch port trunk encapsulation, and you have negotiate ISL and .1Q. Like I said, the older switches ISL was there. So when you say ISL is a Cisco proprietary inter-switch link, right? It's a proprietary encapsulation technology. In later switches, we don't even have this command because newer switches only support .1q. .1q is a open standard. A lot of, I think almost all the vendors support .1q. So we're going to hardcode this into .1q, right? Now we say switch port mode trunk. Now we are hard coding this into trunk. Older switches, if both the switches supported ISL, by default Cisco switches would take ISL because that is proprietary. If one of the switch only supported ISL and one of the switches supported ISL and .1q and the other switch supported only .1q, it would always take .1q because that's what both of them could do. And like I said, in newer switches we don't even have to consider that because it's always going to be a .1q encapsulation. So when you try that command again, switch port interface trunk, you would see now it's in mode in trunking. Status is trunking, .1q is the encapsulation. Now let's say switch port show interface Ethernet 0/0 and do switch port. So show interface E0/0 switch port, and we see all the statistics for that particular interface. So we see the name is E0/0, switch port is enabled, administrative mode is trunk, operational mode is trunk, administration trunking encapsulation is .1q. It is operating a .1q encapsulation. Then we need to look at a few things. We need to look at the native VLAN. So the native VLAN is here. So it says trunking native VLAN is VLAN 1. That is the default, right? So native VLAN tagging is enabled, right? So if you want to change the native VLAN, we need to say config terminal interface E0/0, and then you come into that interface, the trunk interface, and you say switch port trunk, and then you say native, and we set the native VLAN. So native VLAN, let's say for instance 20. So now I'm going to change this into native VLAN 20. So now I have switch 1, which is with a native VLAN of 20, and I have another switch 2 that is still working on native VLAN of 1. Now you see CDP. CDP is very intelligent. It looks at both the thing and it says there is a native VLAN mismatch. Native VLAN mismatch discovered in Ethernet 0/0 with switch Ethernet 0/0, which has got VLAN 1. So VLAN 1 and VLAN 20. It is giving us that notification saying VLAN has mismatched. Native VLAN is mismatched between the two. So this is the difference between native VLAN and default VLAN. Right. Next, we're going to look at normal VLAN and extended VLAN. Now, for a long time, Cisco only supported VLANs from 1 to 1005, of which VLAN 1 and VLAN 1002, 3, 4, and 5 being default or restricted VLANs, like we discussed. Now, this is called the normal VLAN. But then by default, the VLAN ID, if you remember that VLAN tagging, like I said, the VLAN ID, it's a 12-bit ID tag. So 12 bits 2 to the power 12, is to 4096. So there are 4096 VLAN by default. So everybody had for 4096, but because of Cisco's backward compatibility, Cisco only supported till 1005. So this extended VLAN, the VLAN from 1006 till 4095, Cisco calls it the extended VLAN, right? Extended VLAN. Now, you could use extended VLAN in older devices, but of course you couldn't use it if VTP was enabled. If you had to use VLANs, if you had to use VTP and extended VLANs, then you had to disable VTP in VTP version 1 and version 2, because VTP version 1 and version 2 couldn't relay. If the VTP was working in VTP version 1 and version 2, it couldn't send out those VLANs more than 1005. So if you're using extended VLANs, VTP had to be disabled, and you had to manually go and configure those VLANs in all the switches, because it wouldn't get updated to the VLAN database. If you want to use extended VLAN in VTP, then you need to use VTP version 3. Right? So like I said, normal VLANs are stored in VLAN database. Extended VLAN only in VTP v3 it gets stored in VLAN database. Now, let's look at show VTP status. Now this particular switch is working on VTP version 2. It supports 1 and 3. I have put a domain name, and the most important thing is it is in server mode. In server mode, it tells here its maximum VLAN supported is 1005. So it can do only till 1005, like we discussed here. It's the normal VLAN that it can do. So let's do this. Show VLAN brief, right? We know that there is a VLAN called VLAN 20, and this VLAN 20 is now, it's here because it is part of something called the VLAN database. Now VLAN database has this. Now let's say show run. This is nowhere mentioned here in the running configuration. There's no mention of the VLANs that's present because VLAN is only going to sit in the VLAN database. So remember this VLAN database, if it is normal VLAN and if VTP is running, VLAN database, like I said, it's stored in the VLAN database. And now, if I, let's say, configure terminal VTP mode transparent. Now VTP mode is, like I said, in older devices you can only do VTP mode server, client, or transparent. Transparent literally means it is not operating, so it's like mode off. But the new VTP also has another option, says VTP mode off. So let's say do off, or let's do transparent. Now it says VTP in transparent mode. Now let's look at the running config again. To show run, and you see now this time the VLAN information is added. So it says there is a VLAN called VLAN 20 and the name is management. This gets added onto the running configuration. So if VTP is in transparent mode or off, and if you add a VLAN, the VLAN gets added into, if you're adding a normal VLAN, that is, if you're adding a normal VLAN, what do you mean by normal VLAN? VLAN numbers less than 1005 is normal VLAN. So if you're adding a normal VLAN when the VTP is off on transparent mode, that information gets added to the running config and to the VLAN database, right? But if you add, let's say in this mode, if you add VLAN 4000 or 3000 and let's say exit, this VLAN information, do show run, it gets added into, obviously because it's in, like I said, it's in transparent mode, so it definitely gets added. All the VLAN gets added to the running configuration. Now if you want to do VTP, if you want to do extended VLAN, we need to go into VTP mode 3. So let's say VTP version, not mode, VTP version 3. If you're doing VTP version 3 and now say do show run, we see that VLAN 3000 and VLAN 20 is still part of the running configuration. Now let's say VTP mode and let's say server, right? Now this is part of VLAN VTP server, it's VTP is gone to server mode. Now say do show run, you will see that the VLAN information has disappeared completely. There is no VLAN information here in the running configuration. There is no VLAN information at all because all the VLAN information is part of the VLAN.dat or the VLAN database. So VLAN database has all the information of VLAN now because now we are running VTP version 3. So let's say do show VTP. Sorry, which version? Show VTP status. Oh God. So sorry, sudden mental block. Okay, so show VTP status, and then we see that it is working in VTP version 3, and now maximum VLAN supported is gone to 4096. So that's that. In VTP version 1 and 2, only normal VLANs are supported in the VLAN database. If you put VTP off on transparent mode, VLAN information is added onto the running configuration. If you want extended VLANs to be part of the VLAN database, you need to go into VTP version 3, which supports up to 4096 VLAN. So that's the difference between normal and extended VLAN. Next, we'll look at data versus voice VLAN. If you remember, I discussed earlier that each of those ports can only be in one VLAN, right? You can only have in one of the VLANs. But we have a lot of cases where we have to configure our IP phone in the port. So basically what happened in older buildings when they wired computers, you used to have a phone line, which used to be the old the phone lines, and then you had the computers like Ethernet lines. Now, over a period of time, phones moved to IP, like you became IP phones, right? So now there was a situation where you had to wire two separate lines coming into the closets, right? To each of those cabins, you will have to have two Ethernet ports coming in, and then you connect a phone and a computer. But that was a little expensive deal, and when IP phones started coming in the market, from the very first IP phones, they, instead of to overcome that shortcoming, all the IP phones came with an inbuilt switch in that. So you could, from the wall socket, you connect a wire connected to this phone. From the phone, you could get a patch cord and connect to your computer, right? So now the problem is that one particular wall socket, whatever that port it goes into, had to have two different VLANs, like we discussed in our day 11 or day 12 video, when you had to loop what happened and what they had to make use of the native VLAN concepts. The traffic comes without tagging and all those things. That was a workaround, but then you had to have a permanent solution. That permanent solution is the concept called data VLAN and voice VLAN. So in this case, you would put all the phone lines, in a VLAN called the voice VLAN, immaterial of what the computer is connected to. Maybe the computer is connected to VLAN 20, this computer is connected to VLAN 30. But in spite of them being in different VLANs, the data VLAN, the voice VLAN, they all went into was the same voice VLAN. So let's say this is VLAN 50, and this was VLAN 20, and this was VLAN 30, right? We would put all the all the phones into VLAN 50, and we would put VLAN 30. So basically these ports, right, had two VLANs. You would have a data VLAN and a voice VLAN. You would have a data VLAN and a voice VLAN. You would have a data VLAN and a voice VLAN. Now, like I said, access VLANs always had one VLAN. You cannot have one port in two VLANs. So I can't put switch port access VLAN 10 or 20 and switch port access VLAN 50. You couldn't do that. So a way of doing that is something called as the voice VLAN. So you would have a command called switch port voice VLAN, and then you put, so that they know that for voice this is VLAN and for data this is a VLAN. We'll look at how it is configured. So basically what happens is any traffic coming originating from the switch from the IP phone would, because IP phone also spoke encapsulation.1q, so they could put itself in VLAN 50, so it will be voice VLAN VLAN 50, and the other traffic that's coming from the PC is going to loop through the phone, and like I said, it's just a switch, so it's just going to patch that traffic back to the switch, and that switch would take it and put it into VLAN 20, because the data VLAN or the access VLAN is in VLAN 20. Alright, so let's get in and do that. So we'll say, what we'll do is we'll create a VLAN 50 first, so VLAN 50. Okay, and we say exit. So a new VLAN 50 is created. So we'll go to interface Ethernet 0/1 switch port mode access. We create hardcode registration to be access port. We did it earlier, but I'm going to do it again. Switch port access VLAN 20, right? And switch port voice VLAN is going to be VLAN 50, right? Now let's do this. Show VLAN. Okay, this is going to irritate me because of this native VLAN mismatch. I'm going to quickly go there and change that. Configure interface E0/0 switch port trunk native VLAN 1. Okay, show VLAN brief. So we see now we have VLAN 50 and VLAN 20. Now this is important. The last time when we changed into a VLAN, we saw that we changed VLANs, the ports automatically shifted from one VLAN to the other. In this case now, VLAN, this port is a part of two VLAN. Now that itself is your biggest clue. So if you see the VLAN database and you see that one port is in two VLANs, you should know that one of the VLAN is a voice VLAN. That's why it's part of this thing. It cannot be a trunk. Now trunk is where, so we can look at it. Trunk is where all the VLANs are loved through. So we say show interface trunk, and we can see that this trunk, all the VLANs are loved through 1, 20, 50 and 3000, but Ethernet 0/0 is the only trunk. So technically, when you do voice VLAN and data VLAN, each of those ports acts like a semi trunk because it's allowing more than one VLAN, but for all practical purpose, it is still um, access port. So you can look at that. You can say show interface E0/1 switch port, and then we see that this port is enabled. It is definitely working as an access port. You can look at the trunking encapsulation, native VLANs, and all those things. These are there as a default configuration, but since it's an access port, you're not looking at the encapsulation and all of those things. You see here, access mode VLAN is 20 and voice VLAN is VLAN 50. So this is how you see if that port is part of two VLANs, one voice and one data VLAN. Another thing is, of course, you can look at show run, and show run. Definitely, if you go into that interface, you will see that that interface has access VLAN 20 and voice VLAN of 50. So that basically covers our difference between data VLAN and voice VLAN. Hope this video helped you. Thank you for watching once again. If you have not subscribed to our channel, please consider subscribing, and please consider hitting that like button. That is your way of saying thank you, right? Thank you once again, and see you back very, very soon.